based on what I was seeing in the 3 o'clock, let me give some practice questions, some checks. I'm going to tell you that I've got a velocity average. I like to write in blue. I'm going to give you that I've got some average velocity is 8 meters per second. And I'm also going to tell you I start at x initial equals 20 meters. Where do I end up after 2 seconds? This is Google question A. Juju question B is, what was the next one? Velocity, the initial equals 12 meters per second. The final equals 8 meters, what the hell, 4 meters per second. Which direction am I moving in? Upward or downward motion? Let me be precise. Which direction is my object moving? And Google question C. What was the third big skill that we were struggling with? No, that's it. I can get with those 2 questions, see where you're at. Oh. Oh. Hey, like 2 minutes, 1 minute, 10 seconds. Wow. Here's your best shot. Chop, chop, quick like a bunny. Okay, time's up. I have got vastly more students correct on the first question than the 3 o'clock section, perhaps because the 3 o'clock section was thinking about things and the question wasn't explicitly separated, or maybe because there are more challenges there. The correct answer for A is 36 meters. The displacement is 16 meters, 8 times 2. And if you start at 16, and if you start at 20, position 20, and you move 16 meters further, you end up at 36. There are, however, still maybe 10% of y'all confusing A. So let me encourage you, I believe, based on the answers that I'm seeing, that it will be helpful If we write x, what does it mean? What does it mean to have a dead pencil? What does it mean to have a displacement? If I have a displacement, that means that my final position minus my initial position is some value. If I write down the values, I told you, I think you all figured out the displacement is 16 meters, and the final position is my unknown. My initial position is 20. This should not be a difficult equation to algebra. What do I do to both sides to get the x final alone? I add 20. 16 plus 20 is 36. If you got 4 or negative 4, let me encourage you, don't guess a mathematical operation to combine two numbers. Write down a definition, an equation which I have promised is always true. For instance, if we're talking about initial and final positions and displacements, write down this equation. If we're talking about velocities and displacements, write down delta x over delta t equals is the defining equation for velocity. If you have something which is always true and you plug in numbers, you're not going to get nonsense. Here's why 4 is nonsense. Think about this, meditate upon this. What does it mean to have a positive displacement? You're going up or right. If I start at 20 and go further to the right, how can I end up back close to the origin? That's the last thing, by the way. For all of y'all, even if you got this right, I want you to meditate upon your answers. If your homework is taking you 5 minutes to solve a problem, spend an additional 10, 20 seconds visualizing the sucker after you're done. Think about your answer. Is it possible? Is it reasonable that you have ended up with a positive velocity? Is it reasonable? The values of velocity, you guys don't come into the world knowing what a meter per second looks like or what a meter is. But with practice, you can get there. I'll tell you 1 meter is about this far. 1 meter per second is about this fast, which is about 2 miles an hour. 2 miles an hour per meter per second. 2 miles an hour is 1 meter per second-ish. That's approximate. If you get a feeling for that, then in lab, when you measure a final velocity to be 20 meters per second, you'll know that that's BS, right? Why is it BS? 20 meters per second, that's 40 miles an hour. No, the cart was not going at 40 miles an hour in the lab. No, there must be a goof here. You'll save rather a lot of time in this semester and next semester if you reflect on results and learn from them and get a feeling for these magnitudes and these quantities. What does it mean if I start at 20 and go further right? Well, I can't end up back close to the origin. I can't end up in the negatives. I encourage everyone to do that all the time for all of the problems. Do a sanity check, if you will. Think about, is this reasonable? Sometimes that's easy, sometimes that's hard, but with practice, it gets easier. Okay, the second one, however, half of you got the answer wrong. That's not okay. Let's talk about it. What is true about upward motion? How do you tell from velocity? How do you tell if you're moving up or moving down? The sign of what? Sign of velocity. Is this a positive or a negative number? Is this a positive or negative number? You're moving upward. The direction your object is moving is upward. Now the number is getting smaller. The numbers are going down. The number representing what? If the number represented position, then you better believe that the object is moving downward. This is not x, this is v. So let's reflect on this. The values of velocity are positive and getting smaller. What do I know? I am moving upward, but slowing down. Good. Yeah. If the numbers get closer, if the velocities get closer to 0, you're slowing. If the velocities are positive, you're moving upward. For instance, an example of this might be if I throw a marker upward, while it is moving upward, it is moving in the positive direction and slowing down. That time interval until it hit the ceiling there, it was moving upward and slowing down. Positive velocities getting less positive. Okay? Reflect on this. There is also a negative thing about this. This is accelerating in the negative direction. This has a negative value of acceleration. Final velocity is less than initial velocity. Fast or slow doesn't matter. If velocity final is less of a positive, more of a negative, whatever number, this minus that is negative, then you are accelerating in the negative direction. Okay? The acceleration does not tell you the direction of motion. That is strictly the sign of velocity. Turn to your neighbor. Again, statistically, half of you are wrong. Turn to your neighbor and argue about this. How do you see, is something moving up or moving downward? Help each other out. All right, now having discussed with your neighbor, ask me a question. Please.
Wondering, so since it has the lower point as the second point, does that imply that it hit its peak because it's going up? So like has that motion that's slowing down because it hit its peak?
Maybe.
That's another way to tell it's going up.
Well, hold on. If the velocity is still positive, then it's still moving upward. If it's still moving upward, I don't think it can be at its peak height.
Well, like what I meant is like it's going up, like it's getting near it, so it's
Getting near what?
down.
Yes,
It's
yes,
near it, so
yes.
it slows down at-
If velocity goes from 12 to 4 to 0, when the velocity ends being positive, if it starts to go negative, then yeah, it's hit a high point. For instance, I'm going to show you the sketch of velocity versus time for a falling object, for a thrown object. Here's velocity, here's time. What's happening here? Where is the object? No, at its high point. It has been displacing in the positive direction. All these v's are positive. It has been moving up in this whole time interval. The position at this time is when it has reached its maximum positive position, because this is all upward displacement. This represents moving downward and slowing and speeding up. This is after you have moved as positive as you can get. Meditate upon that too, by the way. It's going to be big moving forward. If this were a position graph, what would this represent? 0. Where are you? 0 at the origin. But distinguish between where you are and where you're going. Yeah. Yes. Think about this. If velocity numbers are positive, you're adding to your position. Which graph? Velocity graph? If you've got a negative slope, I don't care. Negative slope is bringing my positive velocities less positive. That doesn't make them not positive. Whenever the values of v are positive numbers, you're moving upward. The direction of motion is upward. You're adding v's to your position. Your positions are increasing. Perfect. You got it. Click for you. Yeah. Uh-huh. Do this in lab this week. Go over to the side, grab a ball, toss it up over the motion sensor, and you'll observe. Actually, what you'll see, the full graph will look like this. I am speeding up, moving in the positive direction. When do you speed up moving in the upward direction with a ball? When you are throwing it. This is when your hand is speeding the ball up, going upward. Then the ball rises, slowing, hits a peak, falls, speeding up. What happens here? What is happening to the velocity? It becomes zero. What could possibly be causing that? You're catching it, exactly. The throw, the free fall, the catch. You see it? If that clicks, you've learned something very important and valuable and useful and will get you multiple points on the midterm. Yeah. Yeah, question.
Catching it, like, are we like, I'm confused on the of the graph.
So what is the direction of motion when you're catching something? The direction of motion is down, so what does that say about your velocity? Your velocity values are negative. If direction of motion is downward, your velocity values are negative. Just like we were saying earlier, velocities are positive, it's going up. I don't care whether the graph is going this way, that way, or the other way. Positive velocities, upward motion. Negative velocities, downward motion. These velocities are below the horizontal axis. These numbers are negative. This is downward motion. Your hand is moving downward, but faster, medium fast, slow at rest. Direction, downward motion, coming to rest, right? Your hand is recoiling, but bringing it to a stop. That's this. Is my acceleration positive or negative here? Google form, question C, is this at a positive or negative acceleration here? Google form, question D, am I slowing down or speeding up? Google form, Google, 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 Google. Again, in this time interval, tell me about the acceleration sign and the speeding up, slowing down. Question C is positive or negative. Question D is speeding up or slowing down. Okay, let me follow this up. Acceleration is the slope of velocity. Is this a positive or a negative slope? Positive. Positive acceleration. What's a negative acceleration look like? Shoop. Here's a negative acceleration. Here's a zero acceleration. Here's a positive acceleration on a velocity graph. Yeah. About a third of you told me that's a negative acceleration. No, it's negative values. Velocity is negative and getting less negative. The change is positive. The value is negative. Look, I'm earning $100 today. What's my bank account balance? Positive or negative? No, you don't know that I started at zero. I'm actually owing $100,000. Now I'm owing $999,900. You don't know that necessarily A positive change is the same thing as a positive value. Yes. So question is, on a position time graph, can you have a positive decreasing slope? Absolutely. If you have a negative acceleration and a positive velocity, you're going to taper off. Hold on. On a position graph, a negative slope is down. Negative change is getting downer. Slope is getting steeper negative. Say that again. Decreasing slope is going from a negative number to a negative number to a negativist number. To decrease from a negative number means to go that way. Do you mean a number getting closer to 0? Decrease to me means I subtract from. It does not mean I go closer to 0. If you want me to answer the question as I think you were thinking it, you have to say that the magnitude of the slope is decreasing, or the steepness of the slope is decreasing. Those are different questions. A decreasing negative number gets negativer. A decreasing magnitude of a negative number shallows off. Watch out for that. Watch out for that. Do you guys see the question and the distinction here? Remember, we spent half of the class on this yesterday class. I want you to think about this, meditate upon this, because this is not how people use words in English. We use it illogically in English. We decrease something going closer to 0. Decrease should mean subtract from, right? If my bank account is decreasing and I owe money, does that mean now I'm going to owe $0? No, if my bank account is decreasing, I owe more money. Decrease should mean subtract from. If you have a negative slope, which is decreasing, I interpret that, and I will test you accordingly. A negative thing which is decreasing is getting negativer, in this case, sloping downward. If you want to say that the negative thing is getting closer to 0, a negative slope which approaches 0, shallowing slope, a decreasing magnitude of slope would be going down, but going down less and less. Would look like this on a graph. Yeah.
A is equals to df minus bi by t. So 0 minus something minus 20 meters per second divided by time.
If you were going downward and you come to rest, your acceleration is positive.
We are going to see.
Yes, the velocity is approaching 0.
Then let's say hypothetically we are at minus 20 meters per second.
Sure, negative 20 meters per second becomes 0 meters per second.
Okay, so 0 minus 20 will be minus plus. That way the A will be positive.
Positive acceleration, that's what I said. Yeah, good. Okay, let's move into the slides proper. I mentioned this in passing. It's big. It's a big topic. It's what we're doing this week. So I want to emphasize it. And we're going to get some more tools, conceptual tools at the end of this lecture for dealing with velocities and accelerations and displacements and all. But first I want to bang on acceleration again. This is a very important topic. It's central to our entire understanding of forces later, and kinematic equations and free fall. You must understand this or you're screwed. Oh, did I tell you guys got extra credit? Did you all see that? Last week, I had like 15 different people ask 15 different questions. I was so proud of y'all. Like sometimes I have one person ask 15 questions, and that's good. That's great. I like that. It can be helpful. But to show that so many people were so engaged, that's telling me that on average, y'all are learning something. You're engaged. You're trying. I don't know if you're learning, but you're trying to learn something, and that's worth extra participation points for me. Don't get used to that. I won't always give it. But if you want to take the chance of maybe having that more, everyone ask me a question. Okay, but not right now. Acceleration we have defined as the rate divided by time of the change, delta, of velocity, delta v over delta t. Anytime I have a rate, that means I divide by a time interval. Anytime I have a change of something, that means I've got a delta. Delta V, change in velocity, over delta T, rate of. You could turn the words into an equation, by the way. This is the defining equation for acceleration. It is always true. Whenever I have a, well, I should say, whenever I have a steady velocity, I can steadily changing velocity, a steady acceleration, which is most of the time in this course, you can take a final velocity minus an initial velocity, divide it by how long it took to change that velocity, and you'll get your acceleration value. It's the slope on a velocity time graph, right? Velocity time, this is y, this is x, this is rise, this is run, bang. Okay. What's the slope on a position graph? What's the slope on a velocity graph? Great. I want to emphasize also units of acceleration are not meters per second. Don't get these confused. They're meters per second, or meters per second squared. I screamed inside last year when a student on the final I saw notes or they were talking to me about it or something and talked to me about the free fall acceleration is about 10 meters per second. What? Meters per second doesn't measure acceleration. I think what they were thinking is an object moves at a steady rate when freely falling, and that's not the case, as we will discuss in enormous detail later. So, if you were talking about an acceleration, you were talking about how fast changes. There are two fast time intervals in that. Per second squared, meters per second per second. I also wish to emphasize here acceleration is in general a vector, unless I use the word magnitude or absolute value or intensity, I don't know. Strength of the acceleration, unless I use a particular word indicating that I just want the positive number, acceleration can go negative and positive. What's the big dealio that I made last time about negative acceleration? What doesn't negative acceleration necessarily mean? That's right. Positive versus negative acceleration do not necessarily mean speeding up, slowing down. It would be great if negative 5 meters per second squared meant I'm slowing at 5 meters per second each second. It doesn't mean that. You cannot conclude that. In general, like I said last class, you are slowing if your velocity and acceleration are oppositely aligned. One is positive, one is negative. One is negative, one is positive. If you are subtracting from a positive number or adding to a negative number, your velocities are approaching zero, slowing down. You're speeding up if they're aligned in the same sense, yeah? If your velocity is upward and your acceleration is upward, you are adding to an upward, you are getting upwarder, you are speeding up. Later in the course, we'll talk about spoiler. We will talk about two-dimensional motion where velocity and acceleration are not necessarily in a line. You can have acceleration at right angles to your velocity, and then you have a circle. You're changing the direction, not the magnitude of the velocity vector. We'll get there, not today. Anyway, here we go. Google question E is, tell me 1, 2, 3, and or 4. Which of these corresponds to a positive V and a negative A? Ready, set, go. Start your classmates. You have 2 minutes. This is like a multiple choice or question or whatever. Correct. Incorrect. So many corrects. Okay, time's up. Give me your best guess. Uh, 80% correct? Maybe a little more? Okay, so about 25 of you, listen up. Positive velocity, what does that say? Actually, everyone listen up. Positive velocity, what can you conclude from the sign of velocity? Direction of motion, positive velocity moving upward. If positive velocity and negative acceleration, speeding up or slowing down. Which of these things is moving up and getting slower? 3. Positive velocities, which is incidentally what I just graphed. Here, we identified this as direction of motion is upward. I am moving upward and slowing down. Remember, this is the rising as I am freely flying through the air, slowing down as I get closer to the top. Yeah. Okay. So the correct answer for E was 3. A ball thrown upward before it reaches its peak is moving upward, positive velocity, accelerating downward, negative velocity. Okay, F. What the F? I changed one word in here. Negative velocity and negative acceleration. What do you think? One minute. Okay, we're split 75-25 between 1 and 4. Let's reason about this. If you are moving at constant speed in a constant direction, what's your acceleration, dudes? 0. Constant speed in the same direction, you are not accelerating. That's not an acceleration. So it is not 4. Correct answer is 1. Also, again, reflect on this. We just talked about this in the previous example. What did I say here? Reach the peak position, speed up in the downward direction. This is the ball falling from its peak, right? What's the slope? Negative. What are the values? Negative. Negative slope, negative acceleration, falling from its peak, right? Yeah. It's all one thing, my dudes. It's all one thing. Seek the connections. Okay, I want to emphasize here again, one more time, positive acceleration. Wait, when we had a negative acceleration, that can speed you up. Negative acceleration does not mean slowing down. Positive acceleration does not mean speeding up. You have to think about it individually. You have to know the direction of your velocity before you can tell whether a negative or a positive acceleration gets you further or closer to 0. Further or closer to 0. Okay, Google Form G, tell me what you think here. Can you have acceleration at a time when velocity is 0? True or false? T or F? Hey, real quick, I was shocked at how many of the 3 o'clock section have had calculus. Who's had calc in here? Okay, let me ask in a different way. Can f prime be non-zero when f is 0? Can the derivative be non-zero when the function is passing through 0? Hey, more than half of you. Say this is the function 2 minus x. Y equals 2 minus x. What's his slope? -1, right? What's the derivative of 2 minus x? -1? Okay, so the slope of this is -1. What's the slope here? What's the slope here? What's the slope here? What's the slope here? Does this go flat for a second? Do you see a different slope here? It is absolutely possible to have a change even when the quantity is temporarily 0. Okay? The results on my Google form are indistinguishable from guessing. Question me.
Maybe because that turnaround, throwing the ball out.
So turning around is a form of changing your velocity. If you are turning around, you're not staying at a constant velocity. You're not staying at rest. You know, Harry Potter can throw something up in the air and Wingardium Leviosa that sucker and it hovers, but that's not the way non-magical objects go. They don't go up, hover at the peak, and then drop down. They go up, turn around, and come down. And there's steady change all throughout that time interval. What are you going to say? What are you going to say? You got a question?
I think I just interpreted what
Yeah.
I interpreted it as like the velocity is like constant 0. So like how can you have an acceleration?
But I didn't say velocity stays 0. I said at an
Yeah.
instant. Yeah. If velocity is 0 and then stays 0 even for a millisecond, during that millisecond, the acceleration is also 0. For an instant is shorter than any finite time interval. An instant is a single point along a graph. No finite interval. And there is no finite interval where this graph goes horizontal. The slope is steady. There is one slope through this entire function. Okay? And the follow-up here, the follow-up as well. You can absolutely have a function where the derivative is non-zero. If I say f of x equals -x, his derivative, f prime of x equals -1. Plug in x equals 0. The function is 0. Its derivative is not 0. Okay. So please meditate upon this. Meditate deeply upon this. there is a huge difference between value and change. I want to make the connection. Acceleration compared to velocity is exactly the same as velocity versus position. To say position is zero means you're crossing the finish line. To say that velocity is non-zero means you're moving. Is it possible to move while your position is, for an instant, zero? Sure, I cross the finish line while moving. That doesn't mean that my velocity becomes zero when I'm at the finish line. It means my velocity, but my position is always changing. Velocity is not x over t. Velocity is delta x over delta t. And if your position stays in the same place for any finite time interval, then you better believe velocity is zero. But just because my x at an instant equals zero, that x final does not also have to be zero if x initial is zero. As long as your x does not stay in the same place, as long as your x changes, you still have a velocity. Likewise, analogously, mathematically identically equivalently, a rate of change of velocity can be non-zero even if v is temporarily zero. A is the slope of v. And if v is changing, I don't care what its value is, acceleration is the change in velocity divided by time. Meditate upon this. Turn to your classmates. Please discuss. 2 seconds. How can you change while staying zero, while being zero for an instant?
No, okay. What's that have to do with physics terms? What are you trying to say? Like, I understand. Oh. Yeah. So wait, are you talking about looking like going like that? And if I yeah. Okay. Yeah. So like how acceleration, you know that. Yeah. Okay. 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 Makes sense. No, you don't have to bring it.
Okay, let's see if you absorbed what we just were talking about. Here are 4 follow-up questions. HIJK. Is it logically equivalent to say if v is 0, must x necessarily be 0? If a is 0, then must v necessarily be 0? If v equals 0, then must a also be 0? If x is 0, must a be 0? Ready, set, go. Don't talk to your neighbors about this one, okay? I want to see individually how many of you get this right. So shh, just for a second. Once you and your neighbor have finished these 4, then talk. Shh, it's a secret. Ready, set, go. Looking for a pattern. True or false? Is this logically? Okay, one more minute. Please let your classmates think. Shh. Okay, can I find a pattern in your responses? Three seems to be suckering in half the class. They're all false. Every one of these statements is logically false. Velocity is 0, then x must be 0. I set this is my x equals 0. I'm going to stand here. I'm not moving. Am I at the origin? No. My velocity is 0. My position is non-zero. Now, if acceleration is 0, then velocity must be 0. I'm going to move with 0 acceleration and non-zero velocity. As long as you're moving steadily, you're not accelerating. You got a velocity. Not as many people missed that one. J was the humdinger. If velocity is 0, A must be 0. That's what we just did! That was the previous example! At the peak of motion, you were moving positively, you're about to start moving negatively. At that instant, your velocity is 0. That doesn't mean your acceleration is 0. As long as your velocity is changing, and from positives going through 0 to negatives, that's a change. You are still changing, you still have an acceleration. That suckered in about half the class, even after we spent 10 minutes on it. Okay, meditate upon this, think about this. Just because your value is 0, don't tell you nada about your slope. You can change even if you instantaneously go through a 0. Last one, position versus acceleration. This didn't screw up as many people as the one that we just talked about. Not sure why here. If position is 0, then acceleration must be 0. If you are located at the origin, can you accelerate? Sure, you could be running through the finish line and getting tired, right? Forgive me for not running to demonstrate. I think it would fall on my face. But if your position is 0, that means you're at the origin, at the finish line. Acceleration must be 0. No, you can accelerate. You could be slowing down. You could be speeding up. You could be turning around. If you define your origin to be your garage, you hit the gas pedal. The instant you hit the gas pedal, the car's velocity is instantaneously 0, but it's hopefully going to become non-zero. Your velocity will change. Your position is still in your garage, but your velocity, again, if your car isn't broken, is about to change. There's an acceleration right there. I like that you're connecting that to real world. It's great. Other questions? Okay. Yes.
Okay, the third one.
Yeah.
If the velocity for an instance is 0, the acceleration for an instance will be 0.
No, that is absolutely not true. Does this line have a flat area? Does this line go horizontal? Its slope is always non-zero, even when its value is 0. If velocity is the graph, acceleration is its slope. Just because the value passes through 0 does not mean the slope becomes 0.
Some formula, like formula of
Sure. So the acceleration formula is the change in velocity per time interval. Suppose I've got an object whose velocity is 10 meters per second, and every second it's losing 5 meters per second. Right? So this says velocity at time 0 is 10. I can write t. Velocity at time 0 equals 10. Velocity at time 1 equals 5. Velocity at time, oh, for God's sake, 2. My velocity is 0. My velocity at 3 times 3 equals -5, so on and so forth. I am turning around at the instant time is 2. What's my velocity at time 2? Am I changing? Do I have a slope of -5? You betcha. My velocity is changing, right in the formula. My velocity is changing. I have a slope. Y equals mx plus b, there's an m. And that m is not 0. Good. I like you're connecting with the algebra. Or calculus, take the derivative of that function, -5, not 0. Okay. Time for some magic. 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 We've been talking a lot because it's very important about the relationship between values and rates. What is a value versus how is that value changing? That is perhaps the single biggest, most vital, most screwed up idea in this entire month of class. Value versus change in value. Once that clicks, incidentally, you'll never be able to unsee it. Keep working until it clicks, baby. All of the questions, 2/3 of the questions on the midterm, if you distinguish between what something is and how something is changing, 2/3 of the midterm is BS. It'll take about 5 seconds per question. Don't take 5 seconds per question because you should check carefully. But seriously, strive for until this stuff makes sense. I promise you it can. And it's the concepts and the relationships here can get easy 100% of the time. I promise. Go for it. Okay, that said, we're not just doing conceptual physics. This is not 101. We are also talking about math and calculation and how do I predict the result of an experiment. You need to be able to go from a velocity graph when velocity is non-constant and get a displacement. Integrate. If you've taken calculus, we're going to do the integral. However, this is not a calc-based class. You do not need to know or remember one bit of calculus. There is a very simple idea. If you want to know how much displacement you get, even when your movement is changing, just take the average velocity. What's average? What's an average number? How do I take the average of two numbers? Atom divided by 2. What does the average mean anyway? Hey, get it? What does the average mean? Okay, anyway. What does the average tell you? Average of two numbers is, what's that tell you? If here's number 1 and here's number 2, it's the middle. It's the number in the middle, right? If I've got two positive numbers, is it possible that the average will go negative? No. If I've got two negative numbers, incidentally, will the average ever be positive? No. Right? Okay, so to find the average of two velocities, add them together and divide by 2. That's your first step. V average equals half V initial plus V final. Displacement, half second, displacement is then average velocity times time. That's it. Miles per hour times hours equals miles. Question. Direction. They have a direction. They can be negative. So displacement can be leftward as well as rightward, upward and down, or downward, not and. So whenever, from class 1, whenever I put an arrow on top, that's indicating a vector, something with a sign, as well as a magnitude. Good question. Other questions? This process here really can be straightforward. Again, there are dose steps, 2 steps, 2 steps. Duh. Find the average velocity. How far do you move and which way? Your displacement is v times t. Incidentally, what happens if I divide this equation by t? What do I get? Nope. Let's take this equation and divide both sides by t. What do I get on the left? What do I get on the right? Bam, bam. What is change in position with respect to time? It's, oh my God, it's velocity. Indeed, yeah? So this is the definition of average velocity that I am solving for the numerator. Oh, okay, here. I'm solving for the numerator. Average velocity times time. Of course, it has to be displacement. Now let's apply this. I'm going to tell you that I start from position 20 meters. Here's my velocity versus time graph. Where am I after dos segundos? Apply the method given, and you shall profit. This is Google question L. What is the object's position at time 2 seconds? L. If this proves too hard, I'll show you how to build it up. But if you follow the 2 steps, you'll get there. Ready, set, go. Good. No, no, no. Yes. No. I suggest please do this together with a neighbor, because so far the results are not encouraging. Do this with a neighbor and discuss why you are doing each thing that you are doing. 2 steps, find average velocity, your displacement. Okay, God, it's 3 steps. Your displacement is VT. And then if I tell you where you start and how far you displace, hopefully you should be able to find your final position. Hint, hint, we did it in the very first minute of class. Okay, hold on. The first 60 answers have 50 incorrect. Let's do this piece by piece. 3 steps again. Find the average velocity. We're going to build this up by piece. Find the average velocity. Can we do that? Can we find the average velocity from 0 to 2? Question M, find the initial. Question N, find the final. Question O, find the average. Let's see where the goofs are. Okay, so again, question M, find V initial. Question N, find V final. Question O, oh boy, is find V average. This will show me if there are goofs in the first step. Ready, set, go. Yeah. You only, what do you mean with respect to the graph? What is the initial position of the object relative to the graph? What does the graph show your initial position is? No, the graph shows your initial velocity is 12. This graph does not have an x here. This is not showing x. I am telling you something about time 0. You'll need him later. Incorporate from time 0. But you do not start from x equals 12. I see another big cause of mistake. You have to read the question carefully, people, please. I'm talking about from 0 to 2, not 0 to 4. Read the question carefully. Try again. Okay, time's up on this step. So one of the problems here is reading graphs. Based on what I'm seeing in the results, one of the problems is how do I read a graph? One of the other problems that I'm seeing is what is position versus what is velocity? What does position tell you? What's the fundamental question? My position is 8 meters. What have I told you? Where I am. If I tell you that my velocity is 20 meters per second, what have I told you?
20 meters per second.
Perfect. You're going at a speed of 20 meters per second in the positive direction. You could shorten that and even say the simplest question is how you are moving, how you're going. Where versus how you're changing your position. So what did I ask here? Did I ask where questions or did I ask how fast, which way questions? What letter does V symbolize? What does this number symbolize? Do not confuse these. I tell you where you start. I'm asking for your velocities. You cannot get velocity out of an instantaneous position. Not unless you know how that position changes over some time. You have to get velocities out of the graph that is labeled with velocities on it, okay? So this isn't everyone, but this is about 20 people in the class. Here's how to read a graph. Okay, we're gonna identify a time. Where is the initial time that I care about? Ding! Time 0 is the beginning of the problem in this case, okay? Now move your hand vertically until you hit the line. Ding! Read the XY coordinates here. My horizontal coordinate is 0. My vertical coordinate is 12. That means when time is 0, velocity is 12. My initial velocity is 12. My initial velocity is different from my initial position. My velocity is not 20. My velocity does not start at 20. 20 is where I start. 12 is how I am moving. So please distinguish carefully between those. Second thing, how do I identify my final position? First, I read the question carefully and see that it talking about time 2 seconds. Move your finger back and forth along the time axis until you hit the 2. Here is time 2 seconds along this axis. Now you move your finger vertically, ting, until you hit the function itself. What is my v value when my t value is 2? It is the height of this, ding, 4 meters per second. Okay, so I got a number of -4s. That's you're misreading the question as at the end. A fair number of unknowns, 2s, 16s, 0s, 12. I'm going to move on. Hopefully that made some sense. The last thing is if I start from 12 and end at 0, what's my average of those two numbers? 6. Use the average formula. 12 plus 0 is 12 divided by 2. 12 divided by 2 is 6. Twelve plus 4. 12 plus 4. Which shows, young Harry, that even the best of us might sometimes eat our words, said Dumbledore. I am no Dumbledore. I'm reading Harry Potter to my kids. It's a good quote. Okay, so halfway between 4 meters per second and 12 meters per second is 8 meters per second. Okay, we're not quite done yet. Crap. It's 5:45. Okay, so I'm going to go, it's 5:43. I've got 2 minutes and I intend to use them. Here we go. Once you've found that the average velocity is 8 meters per second, you find the time interval that happened to change from 12 to 4. The time interval is 2 seconds. If I want to find the displacement is, well, time times average velocity. 8 times 2, 16. 16 meters displacement. Does that mean I end at position 16? No, I didn't start at 0. I started at 20. If I start at 20 and move by 16 in the positive direction, Google Form P, last question, where do I end up? I start at 20, I move positive 16, where do I end? You answer this correct, you get to go home. The answer is incorrect, you still get to go home. It is not, I am not asking a velocity question. This is not meters per second, my dudes. Again, I start at 20 and I move further to the right by 16 more units. Where do I end up? The correct answer is 36. There is a graphical method which we will pick up on Wednesday.